Logarithmic differentiation is a technique used to attack more complicated differentiation problems. I use it all the time. It's excellent. So something like this, obviously what I can do is use the quotient rule, and then I can use the product rule a few times. But why would I want to do that when I can use this technique, which will make it super easy? So I'm going to take the log of both sides, and then I'm going to use the properties of logarithms to break this thing apart into more manageable small pieces. And the derivative of the natural log is really simple. It's just 1 over x. So that's another reason why it's good to use, because it's so simple. Actually, I use it whenever possible, because it's very simple. You'll see. So the first thing I'm going to do is take the natural log of both sides. So now that I've done this, what I'm going to do is use the properties of logarithms to break this apart using the division, multiplication, and power rules. So 2 logs dividing each other, that's a subtraction. I'm just going to do it step by step. Like I know absolutely nothing about anything in this whole world. So that's one part. Now here I can use another set of logarithmic rules to break this apart, because when I have 2 items being multiplied together, what I can do is separate them out into the addition of logarithms. So and then the last thing I'm going to use the power rule of logarithms, where I can bring this out in front of the logarithm. So I'll have 3/4 natural log of x plus 1/2 natural log of x squared plus 1 minus 5 times the natural log of 3x plus 2. Now I can finally get to differentiating. Now I'm just going to take the derivative of both sides. I'll end up using implicit differentiation for this. So let me go ahead and do that. Take the derivative of both sides. I'll get 1 over y times dy dx. This will be 1 over x. Now I'll just go ahead and write them together. No, I'll go ahead and just show them like this, just to make it simple. Make it actually more apparent exactly what it is I've done. So this will be 1 over x squared plus 1, and then the chain rule, that will leave 2x on top. Times 5 times 1 over 3x plus 2, then the chain rule, that leaves 3. So I'm going to multiply all this chunk together. So these will cancel each other out. Okay. So now I need to isolate dy dx, and I'm going to do that by multiplying y over to this side. So it'll be equal to y need to do is go back to my original problem and see what my y is. X to the 3/4 square root of x squared plus 1 divided by 3x plus 2 raised to the 5th. I just substitute that in for y and then I'm done. What was it? X to the 3/4 times x squared plus 1 divided by 3x plus 2 to the 5th. And multiplied by all this. And if one really likes punishment, pain, and suffering, they can multiply this out, but I'm not going to do it. This is good enough for me.